This voiceover is going to address the first part of the lecture in regards to range of motion and flexibility. So we're just going to start with some physiological background so that you'll be able to come into class and understand what we're talking about when we're trying to increase range of motion, what structures we're talking about. So to start with some definitions, flexibility is the musculotendinous unit's ability to elongate with the application of a stretching force. This is a little bit different than range of motion. Range of motion is the amount of mobility of a joint, and there's a lot of anatomical factors that might limit your range of motion. We discussed a few of these in class the other day. The first one would be muscles, depending on the composition of the muscle. For example, if it has more collagen than elastin in it, then that would limit some of the flexibility of the muscle, which then could limit range of motion. Connective tissue, and that would include ligaments and joint capsules. So a person might be hypermobile or hypomobile. If that connective tissue is very tight, or they have what we call contractures, that would be a hypomobility of the connective tissue. Letter C is bony structures. If we lose integrity, like through a fracture, or perhaps there's a calcium buildup in a joint, sometimes normal bony prominences can stop range of motion. For example, if we think about the elbow, the olecranon process coming in as the elbow goes into extension, the olecranon process ends up stopping the range of motion with a hard end feel. Another anatomical factor to limit range of motion could be fat or soft tissue as it wedges between the two lever arms. For example, if you have huge biceps and you go to do elbow flexion, it will eventually stop as the biceps approximates to the forearm and you have limited range of motion. The next one is skin. If you have a scar tissue from post-surgical and that begins to scar down, then the skin would be tight and limit your range of motion. You'll see this especially in burn patients. If you ever have the opportunity to visit a burn unit, their range of motion is significantly limited because of scar tissue. Other factors could be edema, pain might limit range of motion, age, and then possibly gender. If we look at connective tissue and the composition, connective tissue supports the body and provides its framework. So it's composed of different kinds of cells and fibrous tissue and ground substances that form it in different combinations depending on the specific connective tissue type. It varies in types, orientation, the linking of the connective tissue fibers, which then can affect the flexibility and its ability to withstand stress. So the mobility of your body is partially determined by the composition of your connective tissue. Connective tissue is composed of collagen, elastin, reticulin, and ground substances, but the quantities of all these substances can vary according to the structure or even just what you genetically inherit, what you're born with. If we look at what each of these structures actually do, collagen provides strength to the connective tissue. Elastin will provide extensibility to connective tissue. Reticulin is a type 3 type of collagen, which is a very weak collagen, so it does provide some structure. And then ground substance, which is an organic gel, provides more movement, so we don't have friction in the connective tissue. Connective tissue can be either very loose or we can have really dense connective tissue. So we have this whole continuum, and some connective tissue in our body will be very loose and some will be very dense depending on its properties, what it's made of, and what it needs to support. Moving on to the neuromuscular influences of range of motion, the muscle spindles and the Golgi tendon organs are sensitive to tension in the muscle as well as in the tendons, and protect the muscles and tendons from injury due to maybe an abrupt change in the tension. So let's start with each of these structures and just briefly discuss them and how they can protect our muscles from injury. So if we look at this slide, the picture on here shows a muscle spindle. The definition of a muscle spindle is that it's a neuromuscular spindle that lies between regular muscle fibers. So it's actually in the muscle belly. The muscle spindles are sensitive to change in muscle length, which could be a stretch, and the rate of change. So both of those have to be present. So muscle spindle will not be necessarily sensitive if you have a stretch that is slow, but if you have a stretch that is fast, then it will cause a message to be sent along the muscle spindles, and we get a sort of reflexive reaction. So if the muscle spindles fire, the reflexive reaction that takes place is a contraction. So we call that a reflexive contraction in this situation when the muscle spindles fire. I know on here that it says reciprocal inhibition, and we haven't talked about reciprocal inhibition, but I just wanted to remind myself that when we will talk about reciprocal inhibition here in a minute, this structure, the muscle spindles, are largely responsible for this phenomena of reciprocal inhibition, which we'll talk about in a few slides here. The next neuromuscular structure that we want to discuss is a GTO, which is a Golgi tendon organ. The definition is it's a long, delicate tubular capsule. It's located in the proximal and distal muscle tendon junctions. So actually does lie in the tendon. You could find it microscopically. They're sensitive to muscle contraction or tension. So if we have too much tension taking place in a muscle, then it'll cause the muscle to react in a particular way, which is the reflex that takes place that's triggered by the Golgi tendon organ, and this is a reflexive relaxation. So if we fire a GTO or we get a message sent along a GTO, because there's too much tension building up in the muscle, it will inhibit the tension in the activated muscle so that it won't tear. So if I can get a GTO to fire by a long, prolonged stretch, and I keep stretching and stretching and stretching, eventually it'll get to the point where it'll fire a GTO, and the message sent to the central nervous system is that we need a relaxation so that the tissue doesn't tear. So the efferent message coming back is that we have a relaxation. We call that a reflexive relaxation. It happens so quickly, it doesn't go up to the central or the cerebrum for that whole message to be processed, but it takes place automatically. Another term for this is autogenic inhibition. So it'll actually inhibit the muscle that is firing or sending the signal. So again, when we talk about these two structures, they're both preventing a muscle from tearing. So in review, let's talk about what happens when you stretch. It all depends on the speed that you stretch. So if you do a slow stretch, so let's say we're stretching our hamstrings, and we're going very slowly, but we continue to stretch and stretch and stretch and stretch, and we could go so far that we put so much tension on the muscles that we cause the Golgi tendon organs to actually fire. It triggers a response to them, and we get this cascade of events or depolarization along this structure to eventually get a message sent to the central nervous system to cause a reflexive relaxation. That's the only message that the GTO will send, is that I need relaxation at this muscle so that it doesn't tear, and that's then exactly what happens. On the other hand, if we do a quick stretch, so I quickly kick my leg up, doing a quick stretch of the hamstrings, and I kick high enough and fast enough, the muscle spindles will then fire, and it sends its message, and the message for that is a contraction. So we have a reflexive, and it should say contraction message. But anyway, it contracts the muscle to prevent a tear of the muscle. So they're both working for us. It's just we don't want to overstretch slowly, and the GTOs help prevent a tear. And we don't want to stretch too quickly or overstretch quickly, and the muscle spindles help control that so that we don't have a tear in the structure. One more concept to discuss. This is the final slide, is reciprocal inhibition. So reciprocal inhibition simply means that we have an inhibition of the antagonist contraction. So if you contract your biceps, your triceps will reflexively inhibit or reflexively relax. So this is a good thing, and you can take advantage of this if you want to increase a triceps stretch, that we can actually get more stretch of our triceps by contracting the biceps. You could do a little experiment with this if you want to stretch your or increase the stretch on your hamstrings. You can do a contraction of your quadriceps, and that should cause a reflexive inhibition of your hamstrings, so you should get a greater stretch. So you could go up to a wall and do a wall sit, hold it for a while, really concentrate on contraction of the quadriceps, and then go ahead and stand up and see if you can stretch your hamstrings further, or just do a hamstring stretch, and you should be able to stretch further. And that's just reciprocal inhibition taking place in the muscle. So this should be a decent background for when we move into flexibility that we're going to be talking about. We're going to take advantage of some of these neuromuscular receptors, the GTOs and the muscle spindles, and how can we work them to our advantage. And so we're going to manipulate those a little bit. We're also going to talk about how do we quantify this range of motion that we've been talking about, or flexibility, and introduction of goniometry. So we will see you in class, and there should be an outline that went with this, so make sure that you get that filled out as well.